Good day everyone. So today I will share how I created this informative and visually engaging poster about the star life cycle. This poster explains the journey of a star from its birth and a nebula to its final stage depending on its mass. First, I researched the life cycle of stars, focusing on two main paths, which is the low mass stars and the high mass stars. I used reliable science sources and noted case stages like the nebula, protostars, main sequence, red giant, and final outcomes like the white dwarfs or the black holes. I also divided the post tree into two vertical sections, left side for the low mass stars and the right side for high mass stars. I then used arrows and flow lines to show progression clearly. To make it visually appealing, I used bright space theme backgrounds and each stage has an image or icon representing it, just like for example the glowing nebula and the red giant. I then summarized complex scientific concepts into short, easy to understand phrases, just like for example, the fusion begins, the expands cooler surface, and also the fading Earth-size remnants. I also added bold titles, consistent fonts, and balanced colors to ensure readability. Each stages includes a brief description and example to aid comprehension. So in this part of my presentation, I will explain how I created this Hertzsprung-Russell or the HR diagram, which shows how stars are classified based on their brightness, temperature, and color. So first, I search on Google for a clear HR diagram background, which I choose one that already had the labeled access. So in the x-axis is the spectral class and the temperature, and in the y-axis, which in the left is the absolute magnitude, and the y-axis, which in the right is the luminosity. And this gave me a clean base to work with. Then next, I studied where the main stars groups are located, which are the main sequence where most stars are, the white dwarfs, and lastly is the giants and the supergiants. This helped me understand where to place the stars correctly. And then after that, I manually plotted a star, and in this case, Rigel is a blue supergiant located in the upper left of the HR diagram. It's very hot and luminous, with a surface temperature above 10,000 Kelvin, and this means that the Rigel is in a later stage of a high-mass star's life, having already evolved off the main sequence and is now fusing heavier elements in its core. Next up is the Vega. Vega is a main sequence star placed near the upper middle left of the diagram. It's hotter and brighter than the Sun with a spectral type A0, and then the Vega is still in the hydrogen fusion stage, and it is the most stable and longest phase of a star's life. And we also have here the Polaris. Polaris is a yellow supergiant located in the upper right area of the diagram. It is cooler than the blue stars but still very luminous. This means Polaris has left the main sequence and is in a giant phase, possibly fusing helium or heavier elements. And also we have here the Sun. The Sun is the middle of the main sequence of the diagram, with a spectral type G2, and it is the prime of its life, undergoing stable hydrogen fusion, and it will stay in this stage for billions of years before becoming a red giant. Next up is the Sirius B. Sirius B is a white dwarf located in the lower left of the diagram. It is very hot but dim due to its small size, and the Sirius B is the final stage of a low-mass star's life, having shed its outer layer and cooled into a dense core remnant. While Sirius A is a main sequence star, it's brighter and hotter with a spectral type A1, meaning it's still in the hydrogen burning phase, but it will age faster than the Sun due to its higher mass. Next is the Proxima Centauri. Proxima Centauri is a red dwarf located in the lower right of the diagram. It's cool and dim. It's in the main sequence stage, slowly burning hydrogen, and will remain stable for trillions of years due to its low mass. Lastly, we have here the Barnard star. Barnard star is also a red dwarf close to Proxima Centauri on the diagram. It is very faint and cool, placing it low and to the right. Like the Proxima, it is still in the main sequence stage with a long, slow evolution ahead. Lastly, I double-check if the placement matched what I learned from reliable sources. I made sure that the diagram is still clean, readable, and informative. Even though I used a background image from Google, I learned a lot by plotting the star myself. It helped me better understand how scientists organize stars and how our sun fits into the bigger picture of the universe. And that's all for my presentation. Thank you for listening.